Welcome to lecture number 2 for the Einstein Maths program, the high performance program for top achievers in mathematics. This is the preview of lecture number 2. I trust that you enjoyed lecture number 1 and have learned some of the main ideas there. What we tried to show you in lecture number 1 was the George Polya method of solving problems such as guessing and checking, in other words, trial and error, drawing a diagram or a picture, looking for a pattern, making a table, solving a simpler problem. These are ideas that can be applied when solving problems. So in the subsequent lectures, we are now going to apply these techniques to see if we can use them to crack some of these problems. Some of them can become quite difficult later on, but not these for today. I trust most of them are within your grasp and easy to follow. Let's go through them and see what they require. Fill in the numbers 0, 2, 3, 5, 8, and 9 in the blocks so that you get the highest possible difference or answer. What is the answer? Well, I think you have to agree that the highest one should be on the top and the lowest should be below it. In this way, you will get the biggest possible difference when you subtract. The question is, how do you get the highest number? How do you get the lowest number? Note, you cannot use a 0 in the start. So you cannot have 0, 8, 3. It's not allowed. You can have 8, 0, 3 if you like, but not 0, 8, 3. So you try this out and see if you can make some progress. Juice bottle. A bottle of juice costs 1 rand. The juice costs 90 cents more than the empty bottle. How much does the empty bottle cost? Think about this very carefully. Be very careful. It does not say that the juice costs 90 cents. No. In that case, the bottle will be 10 cents. It says the juice costs 90 cents more than the bottle. How much does the empty bottle cost? Well, I'll leave you to figure that out. Moving on to sad princess. While walking along a river, you come across a princess. She looks very sad. And you ask her, what is wrong? She tells you that she has lost some numbers and she needs to find them. They are special numbers because they are all between 300 and 600. The middle digit is odd and the other digits are even. The sum of the digits is 13. In other words, when you add up the digits, you get the answer 13. Can you find the lost numbers for the sad princess? And we want to find all of them. How many are there? I think a good place to start with is when you talk about the sum equals 13. Can you think of 3 numbers that add up to 13? What about what? Let's just take 5 plus 6 plus 2. That makes 13. But does this work? No. Why not? Because it says that the middle digit here has to be odd. And the middle digit here is even. So this doesn't work. Now, can you find cases where it works? Can you make it work? I'll leave that to you. Gold bars are stacked like in the diagram. 3 layers are shown. In the next layer, there should be 4. We showed you 3 already. There are 4 bars and so on. How many gold bars are needed to make 8 layers altogether? So the first layer has got 1, 2, 3. How much will there be in the next layers? Right? I think you can easily figure out that. And then finally, you need to find the total for that. Tricky woodcutter. A woodcutter charges $3 to cut a log into 3 pieces. How much does he charge to cut the same log into 4 pieces? Now be very careful. When it comes to the Einstein maths, the most obvious answer is never the correct answer. Well, most of the time, it's not the correct answer. So you might say, well, $3, 3 pieces. $4, 4 pieces. You will be wrong. You need to think this very carefully. What do you think the woodcutter charges to do? Right? Think through that firstly, and that'll help you to get some progress. The dartboard. Zama scored 100 on this dartboard. How many darts did she throw and where did they land? Okay, now you have to try a number of possibilities here, guys. So what can we try? If you try, let's suppose she hits the bull's eye with 2 darts. That makes 40 plus 40, it's 80. Now, is there a 20 there? No. Is there a 17? 40, 40, and 17, that gives us so far 97. Is there a 3? No, that doesn't work. Let's try, what shall we try? 4 times 24. 24 times 4, 96. Now we need a 4 to complete that to make 100. But there's no 4. So that's the problem now. Right, so I'll leave that to you to try out. Let's see if you can get these right before the lecture starts later on. Coin puzzle. Look at the 10 coins placed in the shape of a triangle. Can you move 4 coins and turn the triangle upside down? Can you do it with just 3 coins? Can you do it with 2 coins? Well, that's quite a challenge, right? So when you move the coins, at the end of the day, we want to see a picture looking like this. Exactly like the same picture it started with, but it must be upside down, pointing downwards, you could say. We leave you to try that out yourself. Lastly, page numbering. If all the numbers from 1 to 250 are written down on a page, how many times will the digit 2 be written? Now, how can you get the digit 2? If you write, well, please, do you think you should write down all the 250 numbers? 7, 8, 9, 10, 11, 12. I think we're going to go crazy if you write them all down. But we can see there's a 2 there and a 2 here, right? When will you get another 2? In the next row, you will have 21, 22. You will get a 2 there, but you'll also get another 2 there. You will not get any 2s over here. So think through it like that and see how many 2s you can count altogether. Good, so that is a preview of lecture number 1. We shall see you in the lecture proper. Please join us. See you.